Great.
So I want to say a big thank you to everyone who's joined us today. I have the great pleasure of introducing Tanzeem Choudhury, the fourth speaker in our Human-Computer Interaction Distinguished Lecture Series hosted by UChicago's Computer Science Department. Tanzeem is a professor of information science and computing and information science at Cornell Tech and is the director of the People-Aware Computing Lab. Her work focuses on developing mobile systems to learn about people and leveraging that information to improve people's well-being and quality of life. She is an ACM Distinguished Member and TED Fellow and has been awarded the NSF Career, the MIT Top 35 Innovators Under 35, and a 10-year Impact Award from the Ubiquitous Computing Conference. Tanzeem, we're extremely excited to be hosting you here at UChicago and to hear about your groundbreaking research. So without further ado, please feel free to take it away.
Thank you so much, Sarah. It's great to be here virtually, and I hope I can visit in person sometime soon. So thanks very much for the invitation, and I'm excited to share about some of the work that my group and I have been doing in thinking about how we can tie continuous rich sensing of human behavior with also health intervention. And I want to start by first acknowledging the students who are in my group, whose work I will be talking about. The last three students, John, Choudhury, and Sayed, have already graduated, but I'm going to refer to some of the work, and the rest of the students that you see here are my current PhD students. So I wanted to kind of start by kind of motivating why I got interested, particularly in behavioral health. So for many of us, it has become clearer with COVID-19 and how we feel when we are so isolated and constrained in how we interact with others. Probably, I was thinking that I am giving this talk where 2 days after the U.S. election, where people are probably more interested in refreshing their screens than actually hearing me talk. But maybe it's another context where our mental health and sanity is important. So the biggest challenge is, if we think about all of medicine, right, behavioral health is probably the area where we have the poorest measurement, right? And oftentimes, kind of medicine relies on measuring the problem and trying to fix it. And how do we fix something that we can't measure? And most of the measurement relies on self-reported assessment that doctors administer with patient. Oftentimes they fill it out on their own. Oftentimes they do it in the doctor's office. But it really relies on patients remembering events in their lives, which, when someone has behavioral health issue or are in the depth of depression, the ability to even recall accurately can be compromised. But it's a huge problem, right? There is more than 50 million people in the US alone that suffer from behavioral health problem. Often it's for just like 1 in 5 adults have issues with behavioral health. And the really kind of sad statistics to me is that over 50% are undiagnosed. So we live with mental health issues without ever getting treated for it or even managing it in any way. And that really is not only a huge societal kind of impact, negative impact on the society, but also a financial impact. And I want to kind of say that these numbers look really big, and where do they come from, right? And if we think about one of the areas where the cost really is huge is when we think about chronic illness. About half of US population has some kind of chronic illness, and about a third of those individuals suffering from chronic illness have underlying behavioral health issues. And a lot of times those are not diagnosed. And what happens when you have co-occurring mental health and chronic illness issues is the outcome of the chronic illness is much worse, as well as the cost to treat these patients are often 2 to 3 times higher as well. So it in a lot of chronic conditions, the time to even a behavioral health issue being diagnosed can be more than 6 months, often I think a year or more. And with that time, the chances of a second heart attack, chances of cancer relapse, all these things go up, and it becomes has a huge health impact, as well as the financial consequences of it is also big. So I mentioned that it's hard to measure behavioral health problems, and there isn't any reliable measure. So this is a snapshot of PHQ-9, which is the Patient Health Questionnaire. Some of you may be familiar. This is one of the most widely used assessment tool for diagnosing depression. So if you see, these questions are all about one's behavior and how it has changed over time, right? So there is just the feeling of not having pleasure and feeling depressed, to specific things we do in our daily lives, having trouble falling asleep and energy, and just how you move. If you look at question number 8, is moving or speaking too slowly. So a lot of these signals that are predictive of behavioral health issues is about how we go about in the world and how that changes over time. And of course, one of the last question is about kind of self-harm and whether someone is thinking of causing self-harm and suicide. Again, a lot of the work goes into trying to see if even before someone starts responding yes to that question, do we have enough signal beforehand to intervene? Here are some quotes from patients who actually describe some of these symptoms in their own words, right? They talk about not wanting to wake up, they're having a much better time asleep, I barely had any social context. Again, the aspect of how people kind of physically start changing the speed of where they move is captured well by my leg span. Speech goes fast. I even eat too fast. And sometimes our loved ones, those who we are living with, can pick up on it. My wife can tell by my walk. I've also heard that just by how someone says hello, you can identify a lot of these aspects. So this is where kind of the opportunity of sensing and computing comes, right? So if you think about how people live in the world, their day-to-day behavior and how it changes is something we can really start to capture in a very fine-grained manner right now, right? We can continuously track these subtle signals, which are hard to get in a clinical context. This is an old slide. I think that we have more than 3 billion smartphones that allow us to move from these episodic snapshots, poor adherence, poor accuracy measurement, to continuous, unobtrusive, automatic longitudinal measurements of behavior. And beyond the smartphone, there are more and more devices in our home and on our body that can be used to get rich signals of human behavior. So just kind of to categorize some classes of behavior, right? Of course, how we move around, our physical activity that is important, our sleep, how we socialize. You saw some of these questions come up in the PHQ-9, how we move about, our mood. Also, another aspect that is important and increasingly important is addiction and substance use, because oftentimes people use substances as a means for self-medication when there is underlying behavioral health issues and depression. So if we look at just kind of what can we get from data from smartphones, right? We of course have the the obvious set of sensors like location data and how we use our phone to accelerometer, right? You can get many attributes of human behaviors that are relevant in behavioral health, right? How much time do you spend at home? Of course, now it's very different than it was pre-COVID, but are you at home alone by yourself for long periods of time? Do you go outside? Do you go to work? And how you move about in the world, how you interact with your devices, and not only just whether you have physical activities, the rate of those physical activities is important, often referred to kind of psychomotor changes or psychomotor, the rate of how you're walking, how that changes can be informative. And by combining all these senses, we can also look at information about sleep, whether someone's sleep is getting interrupted, but also you can get at information about person's chronotype, which is in many research, clinical research has been shown to be important for behavioral health. In some cases, the misalignment between your internal kind of body clock or chronotype with how you live in the world can be a trigger for behavioral health issues for certain population. So the sleep is important, but also kind of looking at the routines of some of these behavior can be even more important a lot of the times. So one of the area that we've done quite a lot of work in, and I'm not going to kind of go into a lot of detail in that because some of our early work now you can see are part of the operating system, like OS level signal that you get on smartphones, right, in terms of activity and physical activity, and oftentimes also in sleep, that you can take all these data. There is, of course, a lot of work that goes into kind of making it usable, kind of you're sampling the data in a way so that it does not drain your battery, it does not interfere with your experience of using the devices that you normally do. So, and then you might have missing data holes. So the whole process of how do you take that data and make it into usable signal is one part of the process. But then what we do focus on is often we try to categorize into these buckets of clinical kind of behavioral categories that are used for diagnosing certain health issues, and those what we often refer to as behavioral biomarkers that are kind of relevant symptoms for diagnosing or even managing behavioral health problems. And of course, some of these, there is one thing that to note is in a lot of behavioral health issues and even beyond, these aspects of behaviors are very, very important, but how they change and how they manifest and evolve can be dependent on the specific disease or patient trajectory that we've been thinking about. And one thing I hope that I can iterate over and over again during this talk is what has been really, really important for us in this work is think about both the technical advances and clinical advances. So yes, we can build new sensors, we can build new analysis and intervention, but how do we think it fits with the clinical knowledge and clinical needs and clinical gaps? And one thing I can't emphasize enough is that it can't happen in parallel. It's not that you develop the technology and hand it over, or it can't come from the other side. A clinician can't also tell technologists that I know what I need, you just have to build it for me. It really requires close iteration and interaction from early stages of conceptualization of the innovation and the technology all the way to a clinical trial and beyond. So sometimes things fail because you don't know how to take a successful clinical trial and translate it into clinical practice, which are not the same thing. So I'm going to highlight some of the work in that space of how we've worked in the clinical context, and we'll try to emphasize some things that were particularly important as we thought about designing a solution. So the first thing that we encountered is in the behavioral health context, and it's true for even broadly, right? We can collect a lot of data continuously, and we can feed it into a clinical system. But the problem is that nobody wants to see it, right? The doctors and healthcare system are already overworked, overburdened, and there is not enough bandwidth or even the know-how to understand what to do with this data, how to interpret that data, how to act on that data. So one of the things that is really crucial is, even if we want to use it beyond kind of thinking about in a closely controlled clinical trial, is what do we need to feed into the clinical system that will be useful? So one of the biggest thing is can you alert a care team or the physician that there is something bad about to happen? So can you create a system that just tells them that something bad is about to happen for this patient, right? So it's preceding a major psychiatric event, right? Not feeding them their continuous sleep data, not feeding them their continuous activity data, but just letting them know that we think something is going to change in this patient's behavioral health, mental health state. And it needs to be robust to differences in behaviors, right? So there is no one size fits all, and people's symptom that they exhibit is very different for different groups of people. So for example, the PHQ-9 questionnaire that I had referred to before, some people might be impacted by their sleep and how they're moving around. Others may completely shut down socially, right? Not everyone exhibits the same symptom with the same intensity or even the same subset. So just like with the PHQ-9, there is a score from 0 to 27. Now there's many paths to getting at 25. And similarly, we have many ways to get at a signal that something's not right for a given patient. And we need to be able to kind of identify that. And one path that we took is we wanted to say, what are the tools that people use in the clinical context now? And can we just replace that measure that we know is burdensome on the patient, very sporadic, and use sensors to predict current assessment tools? Of course, there is a lot more we can do and can do better, but that's the kind of first step. So what we did, now this is quite a few years old, is a study called Mood Rhythm, where our goal was that this is often one treatment is called interpersonal social rhythm therapy, where the patients are asked to track the daily behavior along with their mood. And this is particularly relevant in populations who suffer from bipolar disorder. So you can see their key behaviors of when they go to sleep, when they first have human contact, when they're starting their work, have food, meals, and going to bed. This was originally a 17-item survey that got shrunk to 5 items because most people don't fill out 17-item surveys. And what we tried to do is using those signals that we are capturing from the smartphones, say, can we predict those scores, that how regular people are in these behaviors, translate to what's called a social rhythm score. That means kind of how regular is the person's routine and life, and particularly in the for bipolar disorder, that has been shown to be very relevant. So they are much more sensitive to kind of disruption in their schedule and misalignment in their circadian rhythm. So if their routines get really messed up, then they can trigger a manic or depressive episode. So some of those populations are also very sensitive to kind of jet lag and travel. So almost their body has that almost an amplified impact to changes in routine. So what we've tried to do is, first thing is that can we take all these sensors and not expose anything but the social rhythm metric score, so that can we then go from kind of a reactive measure to a proactive measure that we can track someone's SRM score changing. And we saw that we can do it fairly reliably, and especially with the stability status of whether we think someone is trending towards becoming more unstable, we can do it fairly well. So this is kind of one example where we just took our goal was to kind of hide everything and just take what is used clinically today and replicate it using sensors. And one of the advantages of doing that is clinicians know what to do with it. They know this is a score of 0 to 7. They know what to do when someone's a 7. They don't know what to do when you give them a lot of sensor data, right? So it really kind of helps them take action, which is really, really important if you are treating a patient. So we wanted to kind of take this and kind of think about that. What are some things that make this type of inference is difficult? So one of the things that is difficult, which I kind of alluded to, is people are very, very different. Their signatures look very different. So what might be someone heading towards a psychiatric event might look their routine behaviors for someone else. So how do we differentiate that? So one of the things that also I kind of alluded to before, that and the system has to be interpretable by the clinician. So one thing that we worked on building up on our previous work was, we know that there is signal there. And what we also saw is, yes, different people have different behavior. What is really predictive or indicative is not the specifics of the behavior, but how that behavior for that person changes over time. So it's the delta in their behavior over time and the range of that delta and persistence of that delta that is really predictive. And if we take that kind of view, we can kind of actually address variability across people. And also we can look at, think about which aspects of behavior that are contributing to the magnitude of those deltas for clinical decision making. I'll make it more concrete for you. But we wanted to take, so a lot of neural networks are used these days for kind of in the machine learning context for classification. But one thing that often is the case is that it can be a black box system, which is hard to use in the clinical realm. So we took inspiration from some of the work that has been done in a multi-sensor fault detection system using deep neural networks like the encoder-decoder network, where there was, I'm showing you one kind of sensor signal, but you can look at multiple kind of sensors to use a neural network to capture the patterns of the signal, and the kind of a generative model to understand what the signals look like. And then for when you are rolling it out, you use that model to recreate the sensor signal. And if what you've recreated is very different from what you observe, there is an anomaly, right? So there might be in a sensor fault system, like you are saying that there's a fault in the system, and you might have to you should try to look at what the problem is. We actually took that approach of trying to think about multiple dimensions of human behavior as input to look at what their pattern looks like and look at anomalies in their behavior. So this is a study that we did called CrossCheck. It was detecting mental health changes and trying to identify or predict relapse episodes in individuals with schizophrenia. This was actually, and probably when we did that, and to date, it's one of the largest, most continuous data collection effort of individuals with serious mental illness. We recruited about 150 participants. 75 was treatment as usual, and 75 was in our experiment arm. We actually had fairly good adherence in terms of 60 participants actually stayed through most of the study, where we collected data from them for about a year. They were patients with diagnosed with schizophrenia or schizoaffective disorder. They were fairly kind of serious in terms of that they had at least one relapse episode within the last year. And we wanted to see whether we can, through continuously monitoring their behavioral kind of health signals, be able to predict changes and psychiatric episodes. Altogether, we had more than 20,000 days of data and continuous data, and we have lots of data around relapse, but significantly less than the data that we had. And that's often a case also in why looking at anomaly detection is oftentimes serious mental health episodes are rare events. Even things of a relapse or even events like a suicide are rare events. So your system needs to pick up on very important events, right? So your modeling needs to be able to pick that up. So we collected data, self-reported measures along their kind of behavior. This was done 3 times a week of how social, how they're feeling, very similar. There's a lot of overlap again with the PHQ-9. And we also collected in the previous slide, I said the clinician-administered score, which is called BPRS. So what we wanted to do here is to take the similar approach on what we said was sensor fault detection, to say that we're going to take individuals' data around relative days of health and use a encoder-decoder model to capture the behaviors during days of relative health. And our hypothesis is that sustained deviation from routine behavior will occur before relapse. And if we look at the error between our recreated behavior and observed behavior, we will be able to predict that there is a psychiatric event about to happen. And this is exactly what we saw, where you can see the x-axis is showing you days before relapse. 0 is where a relapse event happened. And the y-axis is showing how anomalous was the person's behavior along multiple dimensions from their days of relative health, right? And what you can see, what is encouraging is that there is a sharp uptick that happens almost 30 days before a relapse episode happens. So, and it is sustained, right? So there will be anomalous behavior that happens, whether someone goes, it's during the holidays or they go on a trip or anything, there will be anomalous behavior. But what's interesting here is that you see that the behavior is anomalous and it's sustained, which can be can be used to predict a relapse episode. And what we did see that there's almost a doubling of anomalies across patients compared to days of relative health 30 days before. So this was very encouraging, and because now you can potentially have an early indicator of relapse that where people can take action early, right? When a relapse episode happens or when someone is hospitalized, that patient's time to recovery or getting better is much longer, and also it's very, very costly. So the hope is that by having these early signals, you can intervene earlier and also make it much more affordable. And what we kind of saw is that as we looked at these behavior, like looking at how their phone usage happened, which environment they are in, their kind of how much they're in proximity of those conversations, location visited, the increase and decrease in those trends were really meaningful. So this is just one kind of snapshot of some behaviors where you can see the white box plots are where the days of relative health for certain things about the duration of your conversations, number of incoming. So it's related to phone usage. And you can see these are 2 relapse episodes, and you can clearly see a shift in the behavior when compared to the days of relative health. So we are trying to accumulate all these shifts to get a signal of whether someone is about to have a relapse. So kind of thinking about how we've been thinking about it is, first, can we give something that is clinically meaningful and actionable to physicians and the care team? Can we actually make this signal effective early enough so that adequate action and intervention can be taken before something serious happens? And in that kind of context, I think one of the things that's really interesting, and I think a lot of opportunities for those working in HCI broadly and behavior change and intervention is kind of thinking about how we can create more tighter synchronization between sensing and intervention. And I'll give you kind of a traditional approach that we have taken in the context of schizophrenia, and then kind of move to some new ways that we are thinking about how intervention can be designed by pairing sensing, continuous sensing. So in the schizophrenia context, what we did is we collected data, we inferred kind of symptoms for, and then if it exceeded a threshold, their care team was notified, and their care team would triage all the data and decide whether to reach out to the patient or alert the physician. Again, this is an important kind of step. Even when we were raising alert, not everything requires physician's attention, right? If you think about a healthcare kind of system context, like the physician's time is the most valuable in the way that they have the least amount of time to spare, and also the costliest. So if you can triage some of that information and tie it with other patient data, you are really being kind of sensitive to the resources that are available in a hospital system. But there's also the potential to deliver certain micro-intervention based on the disruptions that you see in their routine to regulate their behavior. And actually, there was a recent paper that just came out by Steve Schuler and his team at UC Irvine, who has done a lot of interesting work on kind of digital interventions that are effective, and saying that some of the most effective intervention can be these micro-intervention that are in context of the user's life and sensitive to the behaviors. So I'll give you one example of what we kind of do, and this work is actually something that's being carried out within Health Rhythms, which is a company that I'm one of the co-founders of. So I also have strong interest in kind of thinking about how we take research out into the real world. So I'll give you an example of how this has been used. So what we wanted to kind of think about, how do you do kind of personalized sensor-driven health program? So yes, you can continuously collect sensor data. And one of the advantages of continuous sensor data is that it can be very passive, and if the user doesn't want to interact with the system, it can measure things in the background. So we don't think health applications or health systems should optimize for eyeballs, right? Engagement, we still talk about engagement and health intervention, but we need engagement when the moment is right. We don't need engagement on a daily basis. And I think a lot of, particularly even in the startup space, and that we think about engagement in the same way of how we think about engagement with Facebook, Twitter, which has its own problems. But with health intervention, I don't think that the right approach is to kind of try to optimize for eyeballs. And so how we took that approach is that the system is just in the background, won't do anything if there isn't a need. But if there was a need, I'll say, over time, we're seeing someone's sleep, and which are wearables that do that now already. But kind of, we are thinking about that. How do you bring all these signals together? You can have a suggestion that is specific only about sleep, right? We're not overwhelming you with suggestions about activity and mobility, right? That people often find lots of suggestions overwhelming. So we just hone in on what specific behavioral signal that we think is declining and try to intervene only along those dimensions. And the other thing that has been shown in a lot of behavioral health intervention, that you want to pair it with often psychoeducation. So you want to tell the patient why it's important, how have others dealt with it. So now we can kind of almost think about shining a spotlight on only the behavior that we think needs to be addressed, giving you specific actions of what can be done, and then also providing some building kind of some of the knowledge or the educational kind of background that you need. Again, often people don't seek out knowledge there. And this is just an early example of how we had different learning content module, but you can think of very different ways of doing that, right? That could be integrated into other things that you can do in your life, like including kind of gaming. And there was a really interesting work done by actually folks at Dartmouth Health System, where they looked at actually providing some of these contents based on your favorite TV shows you watch. So I think there's many ways of thinking about how you build in those contents. And what we looked at was we had a clinical trial where we looked at patients with severe depression, and the suggestion was based on their behavioral data. And sorry, this figure is a bit confusing. So the gray line kind of is showing a trend of a patient who starts up fairly depressed and is improving. And the green, red, and blue lines are showing where our system provided suggestions. Here, and one is just kind of giving you motivational suggestions and background, but then you have suggestions related to specifics to sleep and activity, and they don't all come together. They come based on when we see signals, and they were based on the behavioral data. And what we did was we had a clinical trial where we showed that just pairing this intervention that is tightly tied to your behavior and only focuses on the behavior actually improves the outcome for those even who are undergoing a clinical treatment, so treatment as usual. So we are encouraged by that, and I strongly believe that we need to have this continuous, adaptive, personalized intervention to really leverage the sensing data that we can now collect. Just prediction is not enough. And on that note, I want to kind of end with some of the kind of newer work that we are doing in this intervention space, where we are excited about it, and we think that there could be a lot of interesting future kind of work in this space. So if we think about sensing, right, we had paper-based methods to EMAs we do on the phone, to almost making them invisible, right? Now a lot of these signals just happen because of the devices that we carry or the wearables that we wear or the home that we live in. But can we do it when it comes to intervention? Intervention is still requires active attention from the user. And one of the things that we've been thinking about, so paralleling the evolution of sensing, can we actually design interventions that are much more subtle, much more kind of can operate almost in without conscious awareness of the users? And I'll give you an example of that. And why we believe that that's important is that a lot of these active behavior change requires the users like sense of achievement or determination or overcoming a challenge. Someone who is seriously depressed can't even go about their daily lives. So expecting to motivate them, I think it's just fundamentally starting in the wrong kind of place. So one area that we've been working on is, can we provide these subtle, not really conscious or barely conscious intervention in the moment that helps over time make sustained reductions in people's stress and anxiety. The work, emotion check is one of them, where we wanted to look at continuous heart rate and heart rate variability to provide tactile feedback to reduce anxiety. So imagine like when someone is stressed or have anxiety, their heart rate rises. And now by combining accelerometer data and other where you are, we can filter out things like whether you are exercising or in a gym or in the middle of kind of doing other activities that elevates your heart rate. So there is this whole kind of area in psychology where people study what's called like interoceptive awareness of how people are aware of their bodily signals. There's been some studies that show people who have higher interoceptive awareness are more susceptible to kind of depression and anxiety. So one thing is that, can we provide that awareness in a meaningful way to everyone? So let's say your heart's beating. We can use we actually initially built our own custom solution. Now it can work on a smartwatch, like we have implemented on Apple Watch, that gives you very, very subtle tactile feedback on your heart rate. Now, instead of giving the feedback that your heart's beating at 110 beats per minute, we reduce that feedback. Now it's beating at 60 beats per minute. So in terms of that awareness aspect, that you might think that your heart is beating slower than it actually is. And does that impact your anxiety and stress levels? So we did that in two contexts. The first version, emotion check, was looking at whether people's perceived anxiety goes down with feedback in a stress induction test. We did a follow-up study which called Boost Me Up, that looked at giving that feedback and also looking at how their physiological signal changes. And if we paired it in a stressful event, like we did a timed math test, how it impacts their performance. What we saw was quite interesting. One, we saw that if you give this feedback that gives that feedback that your heart is beating faster or slower than it actually is, you can see decline or increase in their perceived anxiety levels. So this was a self-reported measure of how anxious were they feeling. In the slow heart rate beat case, it was lower. In the faster case, it was higher. What we also saw, which was interesting, is if we look at their heart rate variability, their heart rate variability actually changed. So if we gave them the slow feedback, their heart rate variability was higher, and those who studied kind of stress, higher heart rate variability is actually good. Lower heart rate variability is worse. Usually when you're stressed, your heart rate variability is lower. When you're in moments of calm, your variability is higher. So not only was there perceived stress level, anxiety level, we could influence it. The physiology changed actually, that the actual heart rate variability changed. And also we saw that they performed better in the math test. They were able to answer, the number of correct answers went up. So that was kind of exciting to kind of think about that. Are there opportunities to embed continuous sensing and intervention in this tight feedback loop? And can we go beyond just kind of providing suggestions and messages to think about how we can use not only our entire body, not just for measurement, but also for intervention or the environment that we live in. And I'm going to end with work that is ongoing, so we don't have papers around it, but just to kind of give a sense of where we are going. One area that we want to work, we've been working on is, can we take it in the substance use case where we are continuously sensing alcohol consumption, and this might be those who are struggling with alcohol overconsumption. With my colleague, Rajalakshmi Nandakumar, we are doing, she has done some work based on turning smartphones in active sonar to look at opioid overdoses. So can we continuously in the substance use case, look at these measurements, but also signals of craving. So on the left side, we have like almost like a wristwatch that has some capacitive sensing, and to look at when someone is craving, there is, of course, physiological changes. Often they have goosebumps. So can we pick those up and then deliver intervention similar to the emotion check, but it can be also breathing intervention and other types of, it doesn't all have to be tactile information to potentially address craving, do intervention when we detect craving rather than after someone has started consuming a substance which is harder to stop. So this is kind of work that are really ongoing, but kind of builds on the idea of continuous combination of sensing and intervention. So I want to kind of end by kind of talking about in the clinical realm, people talk about integrated care. And the integrated care is the notion that your body and mind is connected, your physical and mental health is connected. And a lot of health care systems and even payers are thinking about tackling what they call integrated behavioral and physical health problems. And often the challenge has been to bring these pieces of information together to act on it. Although there is an evidence of effectiveness, scaling it to lots of people have been challenging, and it's been very resource expensive. So our hope is that we think about this the ability to continuously measure and intervene at different scales and levels will help realize the vision of integrated care, where we have this continuous measurement that leads to prediction and timely intervention. And this intervention can be direct to the patient as well as to the clinical care team and people who are on the other side of treating the patient, but it can also be the family members and friends and family who are involved in the patient's life. So with that, I will wrap up. Thank you for your time. I want to acknowledge, I already talked about some of my students involved and collaborators, and of course the generous folk who fund the work.
Well, on behalf of everyone listening, thank you so much, and a big round of applause. I want to invite everyone to submit any questions that you might have for Tanzeem, either in the chat here in Zoom or in the chat in the YouTube channel. We'll be monitoring both and would love to hear your questions. We do already have one question queued up, which is from Shihui To, who wants to know, as there may be a substantial difference in the quality of signals that you can obtain from FDA Class 2 devices versus consumer wearable devices, do you foresee software being able to overcome the challenges in getting clear signals from consumer wearables, and in the future have consumer wearables take over from clinical devices on the typical monitoring required for use cases in remote patient monitoring, such as in the mental health use case you just went extensively into?
Yeah, so that's a good question. I think where kind of the FDA's view in this is changing, right? FDA is also looking at kind of software as a medical device and thinking about different new ways where these measurement and sensing-based system can be used. In a lot of those cases, also it depends whether it's being used for diagnosis as well as opposed to someone, your actual physician is making the diagnosis. I think ultimately, yes, I think we will see these devices provide a signal into clinical decision making. I think initially the trickiest is whether we have a device that is making that clinical decision. I think that's still further down the line, but I think one of the things that we have seen is these signals, they might be noisy, but they aggregated over time still gives you very valuable information that you don't have right now. So for example, they can be much better than self-reported measures of PHQ, right? And that also makes it tricky in terms of for a blood pressure device, when you get FDA approval, you have a solid measurement to compare it with, right? And with behavioral health, you don't often have solid measurement, and how even in pharma trials for the pharmacological treatments, which are done in different phases, right? You actually compare it to these assessment, oftentimes in the pharmacological trials for mental health, there is another measure called HAM-D. So I think it's not going to be kind of the traditional way of FDA Class 2 devices, but I think, and then FDA is approving things as digital therapeutics. So I think there will be new ways to use these signals going forward.
Great, thank you. We have a question from Pedro Lopez. Fantastic, Tanzeem. I'd love to know your take on what technologies you wish existed to create more direct interventions. Is it haptic technologies? Is it biomedical devices that can actuate one's own biology or drug delivery? What should trickle down from engineering onto HCI to empower these more direct interventions?
Great question, Pedro. I would, one thing that I've been kind of thinking about is what can we do to really not be locked into intervention in the way we have been doing so far, right? Of like, here's a list of instruction, whether you gamify it or you give it by text message, right? So I would love to see how we use kind of everything that can measure into an intervention device as well, right? Like, can we use can we directly, we brainstorm about like what we call corporal intervention, like what can you do on the body? Can you change its perception of heat, its perception of pressure? And of course, there is visual illusion that has been used for a long time to kind of think about like alter perception to auditory. So I think how do we build devices that are really kind of unobtrusive and almost does not require any attention. But I think in the context of like biology and drug delivery, like there are things that, particularly with mental health, like there isn't any diagnostics for mental health, but there are a lot of signals we still can't get, right? We know people's kind of gut microbiome, the microbiome is important for mental health. We don't have measures for that, right? We don't have continuous measurements of brain signal. There has been just a couple of days ago, Google X announced a thing about a continuous monitoring of EEG. So I think the ability to collect as much information, but I think the challenge is that we have to do it in a very unobtrusive manner. People don't like wearing it, and particularly in mental health substance abuse, it's also a concern about stigma. Or do people think that something's going on with you, right? Like, does it look like you are in almost like with a monitoring device out on payroll? So I think those things of like being able to have understanding of the internal biology, and there's been people talked about in opioid overdose detection, like the delivery, Pedro, you mentioned, like if you detect someone is having an overdose, should there be a device that delivers naloxone, which is used to prevent someone from having like not succumbing to their overdose. So I think that becomes much more of a serious intervention. And I would say that's where there will be a stringent regulation of FDA, but I think that can be also quite interesting.
I might also try to sneak in one question myself, which is, what role do you think both humans and computer-based interventions have in improving mental health? And I guess in another way, what mental health-related interventions are best left to people, and which ones are best left to these like integrated technological devices?
It's an excellent question. I don't think that we should take people out of the system. And I think one of the things that makes mental health treatment effective, part of it is pharmacology, right? Like taking medicine. The other is therapy. And the approach to therapy that will work for you is important, but what is often referred to as therapeutic alliance. How much do you trust your therapist? What bond do you have, right? So I think right now what's happening is just how our healthcare system works, the overburdening of therapists that they're doing in a short amount of time, understanding what the state of their patient is, what their week look like or 2 weeks look like, and trying to create that bond and intervention. So I think the more that we can free up the therapist to do that human connection and bond and build that trust, and provide a lot of almost, I would say, bookkeeping and tracking and exposing the right information so that they don't have to dig through or understand, is the patient remembering rightly or telling me everything that went on, to really focusing on that intervention that they think would be effective, I think is the right way to do it. There are people who are talking about looking into alliance in like a text-based asynchronous, even with a therapy, it's different than face-to-face. So I would love to see that. How do we have that balance and leverage the strengths of both human and computers?
Yeah, great. So I want to just maybe slip in one more question. We had 2 questions very last minute, just kind of we'd like to hear your thoughts about privacy and about this data, security and privacy of this data, especially as it's related to the mental health or health of a patient.
I think it's very important, and I will add like security, privacy, and ethics as well, which is important in this context. So I think there's one is really understanding kind of what is going to happen with the data comes at the very basic level, right? So there has been actually one of my collaborators, John Kane, he says like even doctors' adoption, if they understand why this data is being collected and how it will help them, they're much more open, right? I think often we don't introduce technology with the right framing and explain what is going to happen and what's not going to happen. But then I think there is a lot of work that needs to be done to ensure kind of privacy and security of it. So the privacy, we take it in kind of multiple levels, right? If we're collecting location data, do we need to know where you are, or do we just need to know you haven't left your home, or you used to go to, I don't know, usually 3 to 5 places every week, now you're just going to 2, so meaning maybe you're just barely making it to work and not doing anything else. So I think there's a lot of signal that doesn't even need to leave your device that can be extracted, right? Audio, we have done some work on, like, you don't need to actually even listen to what they're saying. You just need to look at their rate of speech is going and their intonation is flat, right? Much more compared to others. There's, I think, also exciting opportunities in terms of how you think about federated machine learning in this context, because what can happen in the individual devices and what needs to be happening on the cloud is interesting. And I think there hasn't been that much work in that space.
Great, thank you. Well, I think we'll wrap up your seminar there. Thank you again on behalf of everyone listening for your talk and for the Q&A session. Thank you so much.
Great, thank you very much. If there's any unanswered question, feel free to email me. You'll find if you Google.
Great, thank you all for joining.
Thanks.